In the previous video, we understood what a substation is and why it is essential in a power system. But have you ever wondered what actually happens inside a substation? How does electricity enter, get controlled, protected, and then leave to supply different areas? In this video, we will walk through a substation step by step, from the incoming line all the way to the outgoing feeders, and understand the function of each major component. Let's first understand the big picture. Electricity enters the substation through the incoming transmission line, also called the incomer. From there, it passes through multiple equipment that control, measure, and protect the system. Finally, the power is distributed through outgoing feeders to different locations. So think of a substation as a controlled pathway, where electricity flows through different checkpoints before reaching the end user. Let's start with the isolator. An isolator is a mechanical switch used to isolate a part of the system for maintenance. It is important to note that isolators are operated only when there is no current flowing through the circuit. This means they are not designed to interrupt load or fault current. One key feature of an isolator is that it provides a visible gap when opened, ensuring safety for maintenance personnel. So in simple terms, isolators are used to make sure that a section of the system is completely disconnected and safe to work on. After isolating the equipment, we use an earth switch. The earth switch connects the isolated part of the system to the ground. This ensures that any residual or induced voltage is safely discharged. This is extremely important for safety, especially in high-voltage systems where even a small residual charge can be dangerous. So, isolator disconnects, and earth switch ensures complete safety. Next comes one of the most important components, the circuit breaker. A circuit breaker is designed to interrupt current under both normal and fault conditions. During a fault, such as a short circuit, the current increases drastically. The circuit breaker quickly opens its contacts and interrupts the current, preventing damage to equipment. Modern substations use SF6 or vacuum circuit breakers due to their high efficiency and reliability. In simple words, the circuit breaker is the device that actually protects the system by stopping the flow of dangerous current. But how does the circuit breaker know when to operate? This is where relays come into the picture. Relays continuously monitor electrical parameters like current, voltage, and frequency. When they detect abnormal conditions, they send a trip signal to the circuit breaker. Different types of relays are used depending on the protection requirement, such as overcurrent, distance, and differential relays. So you can think of relays as the brain, and the circuit breaker as the muscle of the protection system. Now the question is, how do relays measure such high values of current and voltage? This is done using instrument transformers, namely current transformers, CTs, and voltage transformers, VTs. CTs step down high current to a lower, measurable value. VTs step down high voltage to a safer level. These reduced signals are then fed to relays and meters. Without CTs and VTs, it would not be possible to safely measure and monitor the system. Next, we have the busbar. A busbar is a common conductor that connects multiple incoming and outgoing circuits. It acts as a central node where power is distributed. Different busbar arrangements are used in substations depending on reliability and flexibility requirements. In simple terms, the busbar is like a junction point where power is collected and redistributed. Finally, the electricity leaves the substation through feeders. Feeders carry power to different areas such as residential zones, industries, and distribution networks. Each feeder is independently protected and controlled, ensuring reliable power supply. Now let's briefly discuss some additional equipment used in substations. Shunt reactors are used to absorb reactive power and control overvoltage, especially in long transmission lines. Series reactors are connected in series with the line and are used to limit fault current. Capacitor banks, on the other hand, supply reactive power, improve power factor, and support voltage levels. These components help maintain system stability and efficiency. So now you have a complete understanding of what's inside a substation and how each component plays a role in controlling, protecting, and distributing electrical power. In the next video, we will dive deeper into protection systems and understand how faults are detected and cleared. If you found this useful, make sure to subscribe and follow along this series.